Yeah, so special factoring here, and we're going to factor x to the fourth plus x squared plus 1. Now, if you wanted to try this on your own, your clue is what I've intentionally left up here, which is the difference of squares. But you see no difference of squares here, right? Yeah, but still's got to do with difference of squares if you want to factor this. Now, I already discussed this guy when we factored x to the sixth minus 1. I just did it very briefly, so I thought it deserved its own video. So I'm saying this naturally arises in factoring x to the sixth minus 1. In fact, it arises naturally also when factoring x to the sixth plus 1, that plus sign. Yeah, so both x to the sixth minus 1, x to the sixth plus 1 involve this guy. Anyway, how do we factor it? Well, like I said, this difference of squares was your hint, and here's how it's your hint. You see, we can't factor this. It's a three-term quartic, so we're tempted to think that, like, it's quadratic in form. That is, like, make a substitution that a equal x squared. If we do, we have a squared plus a plus 1. But factoring this is as hard as factoring that, so no good. So recognizing that it's quadratic in form isn't very helpful. So what now? All right, same thing I've said, difference of squares. You see, we would love if this were a 2 right there, right? Instead of a 1 in front of the x squared, if there were a 2, we would love that, because then x to the fourth plus 2x squared plus 1 would equal x squared plus 1 all squared, right? This is a perfect square binomial, right? Okay, cool. But the problem is there isn't that 2. So what do? This is what we're given. Well, you see, we add the 2. We add the 2 here, and we make up for it by subtracting an x squared. That way, we have exactly what we had before, because putting a 2 there and subtracting an x squared is saying that what we have is x to the fourth and then plus x squared plus 1, which is what we've been trying to factor. This is what we're after, factoring this guy. And making that a 2x squared and subtracting an x squared doesn't change anything, right? Like, it's the same as that. Okay. I'm beating a dead horse here. And I already told you that this guy is the perfect square binomial, x squared plus 1 all squared. And then we have minus x squared. So this, which is equal to this, is equal to this. But then this is a difference of squares. It is of the form a squared minus b squared, where a is x squared plus 1, and then b is x. So if we execute the right-hand side, we know it equals a plus b, that is x squared plus 1a plus b, so plus x, and then a x squared plus 1 minus b minus x. There we are. And all we have left to do is write these two quadratics as they should appear, which is in descending powers of x. X squared plus x plus 1, and then times x squared minus x plus 1. Yeah? Cool. All right. I hope you enjoyed this. Take care.